All right, let's take a look at the next section here, which is 8.3b. It's our next group of special right triangles. Again, we're going to look at 30, 60, 90 triangles this time. So this is going to add to our toolkit. All right, our toolkit from yesterday dealt with 45, 45, 90 triangles, where we had 45, 45, and we knew the relationship became A, and A root 2. And we used that to solve some triangles. So today what we're going to do is we're going to add to the toolkit. We're going to look at 30, 60, 90 triangles. And in this first box here, we want to kind of discover the rules here. So they asked me to draw an altitude. All right, so I'm going to draw that in. We could use congruent triangles to show that the left and the right are congruent. So we know the bottom of each of these is 4. All right, so I'm going to go ahead and recopy that triangle out here to the side so we can work on it alone. All right, I've got an 8 on this side, a 4 on this side. And I'm trying to find the length of this altitude A. So A squared plus 4 squared equals 8 squared. That's A squared equals 6, or A squared plus 16 equals 64. Subtract the 16, I get A squared equals 48. All right, when I take the square root of both sides, that gives me A equals, and if I do the simplification work on that 48, I will get 4 root 3. All right, so this last side, the missing side, is a 4 root 3. And again, this is just using Pythagorean theorem, and we have a 30, because that top angle is bisected, and a 60 down here. All right, so if I look at this next one, it's basically having me extend this idea, but to a more general case, where we have an equilateral triangle where each side is 2n in length. Now, they chose 2n to make the bottom of this half triangle a little easier to deal with. All right, it's just going to be an n. All right, so I'm going to go ahead and pull this one out to the side. All right, and just like the numeric example above, we've got a 30, 60, 90 triangle. All right, but this time the bottom's n, and the hypotenuse is 2n. All right, so we're going to do the same thing we did before. We're going to try and solve for that A, all right, which is the altitude. So A squared plus n squared equals 2n quantity squared. A squared plus n squared equals 4n squared. We're going to subtract that n squared off, so a squared equals 3n squared. All right, and then we're going to take the square root of both sides. All right, square root of n squared is just n, but then we're left with a root 3 on the inside. All right, so our a, that altitude, is going to be n root 3 in length. Now what this does is it gives me the ability that if I see a triangle, as long as I know it's 30, 60, 90, as long as there's enough markings to give that, if I know one side, I'm going to be able to find the other two. So if I said this bottom piece was 5, so that's my n. So this side's 2n, so it's 10. And the other leg is going to be n root 3, so 5 root 3. All right, and I'd have my 3 sides to that right triangle. All right, so again, to summarize, when we have a 30, 60, 90 triangle, you're always going to have a short leg, a long leg, and the hypotenuse. All right, the pattern we're going to use is short leg we're going to call A. Then the hypotenuse is twice that, right? Because remember, we cut an equilateral triangle in half. And then from Pythagorean theorem, the last side is A times root 3. So we have A, 2A, and A root 3. All right, so on the next page, we're going to use this to solve some problems. All right, and again, just like with 45, 45, 90s, we're always just going to draw the pattern right in the inside of this. All right, so I've got short leg is A, hypotenuse 2A, and then A root 3. All right, so I look for the section where I know all the information, and I know that on the short leg. So A equals 8. So when I go for X, X is A root 3, so we know that's 8 root 3. All right, when I go to Y, Y is the 2A side, so that's 2 times 8, or 16. All right, and we get our two values for that triangle. Now notice, we only knew one side of this triangle, and the fact it's a 30, 60, 90, and it allowed us to get both of the other sides. All right, so if I jump to this next one, I've got a 30 and a right, so I know it's 30, 60, 90. So I'm going to label it A root 3, and 2A. All right, this is the side that I know everything. So A root 3 equals 9 root 3. Divide both sides by root 3, and I get A equals 9. All right, the X value is just A, which is 9. And the Y value is 2A, which would be 18. So we get our 9 and our 18 for the two missing sides on this one. All right, if I go to the last one in this group, I've got a 60 there, so I know it's 30, 60, 90. So I'm going to label it A root 3, 2A. All right, so I know this side. So A root 3 equals 12. Divide both sides by root 3. All right, so I get A equals 12 over root 3. Now, for standard notation, I need to rationalize. So I'm going to multiply top and bottom by root 3. And I get 12 root 3 over 3, which is 4 root 3. All right, so the A value is 4 root 3. We know from the picture that Y equals 2 times A. So 2 times 4 root 3, which is going to be 8 root 3. All right, so there's my Y value. And then the X is just A, so X equals 4 root 3. All right, so I've got those values from the picture. And again, from one side, I was able to find the other two sides. All right, now the next group is more practice with this, so I'd recommend to go ahead, shut down the video for a second, give these a shot, see if you can pull them off, and then once you're done, come back and check them versus the answers, which I'll get posted up here while you work. All right, so hopefully you gave those a shot. I've worked through them here for you. So on each of them, again, I just labeled them A root 3, and 2A. And the big thing is to be sure that you're putting the A on the appropriate side. The A is always on the short leg, A root 3 on the long leg, and then the hypotenuse is the 2A. And we also have to recognize that they're 30, 60, 90 triangles. Now, this leaves us with one more. It says solve for the variables. All right, so I'm going to look for my options on this one. First thing I notice, I've got a 30 degree down here. So I know this side's a 30, 60, 90 triangle. All right, I also know that this is going to have to be 60 up here, all right, because if I have 30 degrees there, a right angle here, that has to be 60. All right, so on the big triangle, this is A root 3, and 2A. All right, so I'm going to go ahead and steal that. So A equals 4 root 3. Z equals A root 3, which is going to be 4 root 3 times root 3, which is 4 times 3 or 12. Okay, so our Z value is going to be 12. We'll go ahead and put that on the picture. All right. We also know that 2A, the long side, the x plus y side, I could use that if I wanted to get 24. I don't know if it's necessarily going to be helpful for us as we go through. All right, so if I look at this, I had the A was 4 root 3. Z was A times root 3, so I got 12. Now I'm going to focus in just on this little triangle here to find Y and W. All right, so this is another 30, 60, 90, so I'm going to change colors here. So this side is the A, this side is the 2A, and this side is the A root 3. All right, so what I do know is that Z is 12, we just found out. So I'm going to say 2A equals 12, so A is 6. All right, W equals the A there, which is 6. All right, and Y equals the A root 3, which then would be 6 root 3. All right, so now we've got W and Y, and now you've got tons of choices on how to find X. If you want to find X, you could use a 30, 60, 90 triangle again. You could use altitude to the hypotenuse. Tons and tons of choices. Since we already have W is 6 and Y is 6 root 3, I'm going to actually use our rule from last chapter and just say that W equals the square root of X times Y. So W we found out was 6. 6 equals the square root of X, which we don't know, times Y, which is 6 root 3. I'm going to square both sides. 36 equals 6 root 3 times X. We'll divide by 6 root 3. All right, that takes me to a 6 over root 3 equals X. I'm going to rationalize. So multiply top and bottom by root 3. I get 6 root 3 over root 3 times root 3, or root 3 squared. All right, and when I do that, I get 6 root 3 over 3, which is 2 root 3. All right, again, lots of options to work through that one. We could have just said it's going to be half this side because we had another 30, 60, 90 triangle. So again, totally up to you how you approach that. There's a lot of routes through some of these problems. All right, hope that helps. Have a good one. Bye.